Okay, let's just jump right in with a question. Look at this view. Is it worth $50 million? dollars? I mean, that sounds kind of absurd, doesn't it? How on earth do you put a price tag on something that feels, priceless? Well, believe it or not, economists have a really clever tool for exactly that. Today, we're going to dive deep into something called the choice experiment. It's this amazing method they use to figure out the hidden dollar value of things you can't just, buy off a shelf. Things like clean air or even protecting endangered species.
And this gets to the heart of a huge problem for anyone in charge of making big decisions. Think about it. A new factory? That's easy to calculate. You've got jobs, tax money, building costs, all clear numbers. But a forest, its value is in stuff like biodiversity, beautiful hikes, clean air. None of that comes with a price tag. So how do you even begin to make a logical choice between the two?
So, to crack this problem, researchers had a brilliant idea. They realized, hey, what if we stop asking people what something is worth directly? Instead, they found a way to figure it out indirectly just by looking at the choices people make. And that's the choice experiment in a nutshell. It's basically a really carefully designed survey. But here's the key. Nobody asks you to name a price. Nope. Instead, you're given a kind of menu with different options, different scenarios. And all you have to do is pick the one you prefer. That's it. Sounds simple, right? The real genius here is how different this is from the old way of doing things. If you just ask someone, hey, would you pay $20 to save this park? A lot of people will just say yes, because it sounds like the right thing to do. They call this yay-saying. But with the choice experiment, you're forced to make a real trade-off between different plans, each with its own pros, cons, and costs. And that's how the real value gets discovered. It's not stated, it's revealed. Okay, so how does this actually work? How do you build one of these things from the ground up? Let's walk through a quick example. Imagine we're trying to figure out the value of turning an old logged forest into a beautiful protected bird sanctuary. All right, so every choice experiment has 4 basic building blocks. First, you have attributes. These are just the key features you care about, like the number of bird species or the size of the forest. Then each of those attributes has different levels. Think of these as the different settings, like you could have 5, 10, or 15 bird species. An alternative is just one complete package deal, like a combo meal. And finally, the choice set is the menu itself, the different alternatives you're asked to choose from. And this right here is a perfect example of the menu of ingredients. The researchers lay everything out like this. You've got the attributes, bird species, forest size, number of visitors, and, of course, the cost to you. And for each one, you have different levels. They'll mix and match these to create all the different plans you'll see. Okay, so this is what you'd actually see on the survey. This is one choice set. You've got 3 different alternatives. Option 1 is the status quo. Basically, do nothing, and it costs you nothing. But look at option 2. You get way more bird species and a bigger forest, but fewer visitors are allowed, and it'll cost you $20. Option 3 is somewhere in the middle. So which one would you pick? In a real survey, you'd answer a whole series of these, each with a different mix of options. All right, now for the really cool part. This is where the magic happens. How do all these simple little choices, picking A, B, or C, suddenly turn into a cold, hard dollar amount? The secret is that your individual choice doesn't matter nearly as much as the overall pattern. When you get thousands of people making these choices, powerful statistical models can start to see the trends. They can see, on average, what people are willing to give up to get something else, like how much more are they willing to pay to get those extra bird species. It's all about tracking those trade-offs on a massive scale. And the whole point of this, as the source material says, is to figure out what they call willingness to pay, or WTP. But here's the thing. It's not about the willingness to pay for the entire sanctuary. It's about finding the value of each individual piece. What's the price tag on one extra bird species? How much is one more hectare of forest worth to people? And that brings us to this key concept, implicit value. It's the value that is implied by all the choices people made, even though no one ever asked them for a number directly. The computer crunches all the data, all those collective decisions, and then it can actually tell you the precise dollar value for each and every one of those attributes. Okay, this might all sound a little abstract, so let's bring it back down to earth with an incredible real-world example from Australia, where this exact method was used in the fight to save a place called the Macquarie Marshes. So the situation there was really, really bad. For decades, water was being pulled away for irrigation, and it was absolutely devastating this vital wetland. We're talking a massive drop in size, water birds could barely breed anymore, and tons of endangered species just disappeared. The government had this huge, difficult question on its hands. Was it actually worth spending millions of taxpayer dollars to buy back water from farmers to save the marsh? They had to know if the public thought the benefit was worth the price tag. So what did they do? They launched a massive choice experiment. They figured out the key attributes, things like the impact on jobs, the size of the wetland, how often birds could breed, and of course, how much it would cost each household. Then they created a bunch of different scenarios for restoring the wetland and presented them to 1.5 million households across the state, asking them to pick the future they wanted. And the results were just incredible. The analysis spat out the exact value that the average household placed on each improvement. You want to save one extra endangered species? That's worth $4.17. Want to help the birds breed every year instead of every other year? That's worth a whopping $25.83. They literally created a price list for restoring nature.
So, when they bundled together a pretty moderate restoration plan, the models showed that the average household was willing to pay $36.50 for it.
Now I know what you're thinking, 36 bucks. That doesn't sound like a game changer. But remember, that's just for one single household. And this survey, it went out to a region with 1.5 million households. So you do the math, you multiply that willingness to pay by 1.5 million households, and you get a total societal value of around $55 million. All of a sudden, policymakers had this huge, solid number. It was the justification they needed to spend real money to save the marshes. It literally turned this priceless environmental benefit into a concrete economic number. So you can see this is an incredibly powerful tool, right? But it's not a silver bullet. It's not perfect. And like any tool, it's really important to understand both its strengths and its weaknesses. The big strengths? Well, it gets around that yes-saying problem we talked about, and it lets you put a price on the individual pieces of a project, which is super useful. But on the flip side, these surveys can be pretty tough for people to fill out. They're cognitively demanding, and there's always a risk people will just take mental shortcuts. Maybe they always pick the cheapest option, or they just stick with the do-nothing option because it's easier. And that leaves us with a really big question to think about. We now have this tool that lets us put a number on things we thought were priceless. It gives us a way to weigh the value of a wetland against a farm or a forest against a factory in the same economic language. So now that we can systematically measure these things, what are the difficult choices that we're no longer allowed to ignore?